but it can also be very calm as you hear now. Our objective is to analyze the soundscape of an environment from an acoustic point of view and for several areas, as this will be especially important for humans' well-being. So my name is Mohammed Amin Hamami, and this is joint work with Professor Christophe Claramont. Our demo paper title is An Acoustic and Psychoacoustic Experimental Setup for Analyzing Urban Soundscapes. Soundscapes are an integral part of the richness of an urban landscape. A soundscape can be defined as the set of sounds emanating from a landscape from which we can distinguish physical, biological, man-made, and machine-made sounds. Our demo paper introduced an experimental setup to record and analyze the characteristics and spatio-temporal variabilities of an urban soundscape. An experimental psychoacoustic setup is developed and applied to the urban environment of the Tunisian city of Sidi Bou Said. Sidi Bou Said is a historically rich city with diverse soundscape atmosphere and is considered as a relevant model for our approach and future work. Our approach is based on acoustic and psychoacoustic measurements and analysis of auditory scenes in relation to the spatial and the specific characters of the places. Our approach denotes a place description by performing a landscape analysis. Listening to the psychoacoustic environment, approach it on several levels by integrating different distance, close and distance, and orientations, left, right, above, below, front, back. A morphological description of the space based on the acoustic and architectural properties, and a description of the modalities resulting from signal processing, spectrogram, ambisonic, three-dimensional visualization. This dual approach from the sensor to the human supports the analysis of the objective and subjective correspondence between the measured in a wide range of space with the human's perception of the environment. For our experimentation, three main places are selected at the start, a fountain, in the middle, Sidi Amour Cafe, and at the end of the main street, the cliff. In situ measurements are carried out using a Zoom H3 VR recorder that supports 316 audio spatial-based recordings using first-order ambisonic microphones. All recordings were performed with protection of the microphones against the wind. The configuration of the audio files used is 48 kHz and 24 bits. Acoustic measurements were made using a calibrated sound level meter. And finally, a 316 camera calibrated with the direction of the ambusing microphone to obtain the audio and the video synchronized on the spatial direction. For each point, an installation was carried out with the equipment while taking all necessary precaution for the success of the experiment. Several editing steps are necessary to edit the 3D sounds and the 316 video, and especially to respect the synchronization to have correct and precise results. The result will be a 316 video with binaural sound that permit us to be on total immersion with the experiment. This analysis is conducted with several methods, but especially ambisonic visualizations, such as the ones presented show typical sound pattern in 3D space. Sound are specially characterized and located in a 3D time metric space, left, right, back, above, and qualified by their intensities and frequencies. Space is currently integrated as a 3D temporal soundscape that involves and that supports characterization of different locations.
اكيد ايه شكون قال عكس هذا؟ شكون قال عكس هذا؟ كما قال حافظ رياض بالطرح شكون قال عكس هذا؟ شكون قال عكس هذا؟ كما قال حافظ رياض بالطرح شكون قال عكس هذا؟ شكون قال عكس هذا؟ كما قال حافظ رياض بالطرح يا اخي شكون قال عكس هذا؟ شكون قال عكس هذا؟ كما قال حافظ رياض البيض الطرح.
This experimental approach develops an environment of ambisonic recordings and psychoacoustic measurements for the visualization and interpreting different soundscape atmosphere. Taking into account the temporal component makes it possible to reflect the diversity of views and soundscapes along an urban street environment and to qualify the diversity of the soundscape. On the technical level, other types of multidimensional sensors could be explored. Just as visualization tools developed still need to be more fully integrated within specialized systems. We plan to develop interactive integration of ultimate multidimensional soundscapes, immersive and panoramic analysis with an integrated interface. Our approach may be of interest for urban planning decisions and should be reinforced by application to other urban contexts.